Hi, I'm Anne, and today I'm presenting Proxemics for human-agent interaction in augmented reality. This is work done with Pascal Knierim, Francesco Chiossi, Louis Chuang, and Robin Welsch. This project revolves around a central question, which is, does a virtual agent occupy space in an augmented reality or AR environment? We're interested in this question because we know that augmented reality overlays virtual content into physical space. But not much is known about whether virtual objects, particularly a virtual human-like avatar, has a personal space and how might this impact the user's behavior in terms of social interaction. Now, proxemics research is a science of how people utilize space. It suggests that people often maintain a personal space, which is a circular region with a radius of 1 meter that serves as an invisible buffer from one another. Additionally, 4 zones have been quantified based on an individual's preference for interpersonal distances, which include intimate distance, personal distance, social distance, and public distance. These metrics have been operationalized in HCI research to create, for instance, ubiquitous computing systems with context awareness, such that they allow for comfortable interaction with the users. Now, how about for AR, where the realism of virtual agents might still be perceived differently as they stand in contrast to a physical environment? In our study, we asked whether people would respect the personal space of a virtual agent in AR as if they would keep a distance with strangers in real life. Furthermore, whether violation of personal space would lead to discomfort, as evident in the user's physiology. Our findings implicate how comfortable social AR interaction can be realized. To answer our questions, we conducted a within-subject study to explore how individuals interact with 6 virtual agents in an art gallery context.
Hello there. Please go to the artwork on the right. Please rate the artwork.
There are 2 blocks with slightly different tasks in the experiment. Approach the virtual agents in the first block and walking through them in the second. In both blocks, participants would start from an initial distance of 2.5 meters. These are some schematics for illustration purposes. The primary variable of interest was the user's proxemic pattern divided into 2 indicators. Distance when the user approaches and greets standing in front of the virtual agent, or preferred interpersonal distance, or IPD for short, and the spatial distance when the user walks past the agent to view the art exhibit. Participants' physiological responses were also measured to evaluate the degree of perceived comfort when walking through the virtual agent. First, our results show that most people, 31 out of 42 people, kept a personal distance with the virtual agents, and 11 people kept a social distance with the virtual agents. No one kept a public nor intimate distance with the virtual agents. Secondly, human-like agents produce smaller IPD when participants approach them to start a conversation as compared to the pillar. This is shown by the figure on the left. Here you can see that the mean preferred IPD in meters for each virtual agent. We also found gender differences that IPD was enlarged when approaching male agents as compared to female agents, shown here on the right figure. This replicates effects that are typically found in human-human social interaction. Lastly, participants also showed elevated skin conductance responses for some agents. The figure on the left shows the maximum amplitude for all virtual agents as a function of block. The right shows an example of one participant's skin conductance response, indicated by the orange line, when walking through the agent as compared to passing around the agent on the side, indicated by the blue line. Taken together, our study shows that virtual agent occupies a personal space. Human-like agents invited a closer IPD compared to the pillar, where male agents produce a larger IPD as compared to the female. We also saw elevated skin conductance responses when the agent space was violated. Our work has clear implications in terms of designing for a comfortable social AR experience. First, the personal space around the virtual agents can be explained by the presence of their social features and their perceived gender. Some people may hold a stronger perception towards these virtual agents in terms of their size or appearances, as seen in the distances they kept during interaction. Therefore, it is worth for future research to consider how these characteristics would influence how users decide to interact with the virtual agents. Second, conflicts with the virtual agents could negatively impact social interaction. For example, in an enclosed physical space, the presence of an agent in AR could introduce discomfort in users because the agents might be standing too close to the users. Similarly, for designing a pervasive AR interface, which aims to be aware and responsive to the user's context, such that it allows continuous access to information. So having technology like the Microsoft Mesh or holoportation for remote collaboration, privacy could become a concern on this continuum. Therefore, respect for others' personal space becomes important when users attempt to teleport into each other's space. Lastly, our work envisions the incorporation of proxemics aware in physiological computing systems that could support comfortable social interaction with virtual agents in, for example, the metaverse. The takeaway here is that social AR experience with avatars must be designed with proxemics in mind. Thank you.